So for those of you that missed class yesterday being Tuesday, we worked on a practice of exponents, and I'm going to take you through the following 10 problems, and basically this should be done in preparation to take the quiz. What I'm going to do in addition to practice number 1, I'm also going to do a practice number 2. And what this will allow you to do is get additional practice going through each one of these problems and then being able to take the exponent quiz. So let's go ahead and get started. We're supposed to simplify each of the following expressions, and our answer needs to only contain positive exponents. So, when it says to simplify, it means I need to pull it all the way apart and then put it back together where I have one number, so that 3 is going to have one single exponent. So I'm going to go ahead. Sorry about that. So I'm going to go ahead and write the following. I know that 3 has got no exponent on it, so therefore I know that there's a 1. So I'm going to rewrite 3, and then I'm going to multiply it. And then this 4 tells me I'm going to do repeated multiplication of what number? The base of 3. So I'm going to write 3 times 3 times 3 times 3. So how many times did I write 3? I wrote it 1, 2, 3, 4. Why did I write it 4 times? Because the exponent tells me that I should have written or repeated multiplication 4 times. So then all I'm going to do is I'm going to count up the number of 3's. So I've got a base of 3, and what is this being raised to? I'm raising it to the power of 5. Then what I need to do is I need to input that value into the calculator. I need to multiply 3 times 3 times 3 times 3 times 3. I need to input that into the calculator, and when I do that, I get a value of 243. So I have simplified this expression of 3 to the power of 1 times 3 to the power of 4 to be simplified to 3 to the power of 5. And what is the value of 3 to the power of 5? It's 243. So let's go ahead and do number 2. So again, I know that there's an exponent of 1 on the 4, so I'm simply going to write 4 again. And now I'm going to notice that I've got 4 squared, which means I'm going to take 4 and I'm going to multiply it twice. So now I have a total of 1, 2, 3, 4's, so I can write 4 as my base. That's my base. And what am I raising it to? I'm raising it to the power of 3. How did I get the power of 3? Well, I added 1, 2, 3, 4's. I'm multiplying it 3 times, therefore 4 to the power of 3. Now I need to find the value of 4 to the power of 3. How do I do that? I use my calculator and I go 4 times 4 times 4 again. And when I multiply 4 3 times, I know that that answer is 64. So, on the real quiz, you are going to have 2 problems that look just like this. Okay, so moving on. Now we are looking to simplify again, and this time I'm asking you to again get my answer, but my answer should contain only positive exponents. So again, this time I want you to notice that I no longer have just straight numbers, that I have letters and numbers together. So what I'm going to do is I'm first going to pull this all the way apart. What does that mean? It means that I've got 3p squared times p squared. So notice what I do. This 3p squared means I've got 3 times p times p. Why did I write the p twice? I wrote the p twice because I've got a exponent of 2. So then I'm going to do the following right here. I'm going to multiply that by p times p. So now what do? I'm going to add up all the p's. 1, 2, 3, 4. I've got repeated multiplication. Therefore, I know that p is going to have an exponent of 4. And what do I do with the 3? Well, the 3 is being multiplied by p to the power of 4. So I can simply write 3 times p to the 4, or shorthand is 3p to the power of 4. So again, I just put it all together. So let's go ahead and do number 4. I'm going to do the exact same thing. I'm going to notice that I have an exponent of 3 on the n. So therefore, I know I can write n times n times n. Okay, so I've taken care of the 3 on the the 3 is the exponent. It means repeated multiplication. What am I multiplying 3 times? I'm repeated multiplication of the n. So now I'm going to go ahead and I'm going to come down, and I've got a multiplication sign, so I'm going to drop that in. And I've got 4 times, because a 4 and an n next to each other means sorry about that. Fire alarm went off. So let me continue. So I've got my 4, which is being multiplied by n to the power of 3. So now I'm going to take that n to the power of 3, and I'm going to write it 3 times. 1, 2, 3. So now I've got a whole bunch of n's. 1, 2, 3, 4, 5, 6 n's. It is all repeated multiplication. Look at, I'm multiplying all of those together. Therefore, I can write 4 is being multiplied, and I've got n to the power of 6. Where did I get the 6? I've counted up all the n's, put an exponent of 6, and now I've got 4 times n to the power of 6. Now I can put this all together and write 4n to the power of 6. So that's the first page, problems 1 through 4. Now I'm going to go ahead and turn it over on the back side, and you could see that I've got 5, 6, 7, 8, 9, and 10. So number 5 looks just like number 3 and number 4. So I'm going to go ahead and do the exact same thing. If you'd like, I'm going to go ahead and do it, but if you want to go ahead and check it, go ahead and you can pause the video, you can try it on your own, and then work through it, and then check your answer. I'm going to keep going. So I know that this is 3 times n times n times n, and I'm going to multiply n 4 times, so I've got n times n times n times n.
Good morning. That was a alarm.
Sorry about that again. So now, take a look. How many n's do I have? I can count them all up. 1, 2, 3, 4, 5, 6, 7. So I've got 3 times n to the power of 7. So one of the things I want you to note is take a look at that 3 and the 4. Take a look at what I've got, 7. So if I add these two together, I get 7. But I really encourage you to pull it all apart. Okay, so now let's look at number 6. Number 6 looks completely different than number 5, looks different than number 4 and number 3. Why do I say it looks different? Well, take a look. I simply have 3p squared times p squared, n to the power of 3 times 4, n to the power of 3. I have 3n to the power of 3 times n to the power of 4. And now all of a sudden, for number 6, what do I got? I've got parentheses. So what does that mean? Well, what's inside the parentheses? Inside the parentheses, I have x raised to the power of 3, or x to the third power. And then what's happening to this x to the third power? It is being raised to the power of 4. So that means repeated multiplication of what? Repeated multiplication of x to the power of 3. So that means I'm going to take x to the power of 3 And I'm going to write it 4 times. So I'm going to go x to the power of 3 times x to the power of 3 times x to the power of 3 times x to the power of 3. So take a look. Doesn't that look like what we were doing over here? So I can take this one step farther, and I can go x times x times x, because that's what this means, repeated multiplication. And I can write it again, x times x times x. And again, x times x times x. And one more time, x times x times x. So I've split all of these up. And now I've got a bunch of x's. Well, notice, in my bunch of x's, they're all being multiplied. So therefore, I can simply say x to the what power? We'll count them all up. 3, 6, 9, 12. X to the power of 12. So, want to point out, what's 3 times 4? 3 times 4 is 12. Okay, so let's go on. Let's look at number 7. So now I've got 4n to the power of 3. This whole thing is being raised to the power of 4. So what does that mean? It means I've got repeated multiplication of what? I've got repeated multiplication of 4n to the power of 3. And how many times do I have to write it? 4 times. So let's go ahead and do that. So, moving on. So, remember what I said. I'm going to write 4n to the power of 3. And how many times am I going to write that? I'm going to write it 4 times. So, I'm going to write 4n to the power of 3 times 4n to the power of 3 times 4n to the power of 3 times 4n to the power of 3. Take a look at that. So I've got 4n to the power of 3, and I wrote it 4 times. Why did I write it 4 times? Because that exponent of 4 says repeated multiplication. But I'm not done yet, because I still have n to the power of 3 that I could pull apart. So I can go 4 times n times n times n, and then 4 times n times n times n, and then 4 times n times n times n, and then 4 times n times n times n. So now look what I've got. I've got all these n's, and they're all being multiplied. So remember, all I have to do is add up all the n's. So how many n's do I have? Well, I have 12 of them. I know I do, because I've already counted them. But wait a minute. I got all these 4's. Well, I got to multiply all that together. I got to take a calculator, and I got to go 4 times 4 times 4 times 4. Well, when I use a calculator and I do that, I get 256. So, my final answer is 256 n raised to the power of 12. So, see if you can do 8 on your own. If not, you can keep watching the video, because I'm going to work it out myself. So what I'm going to do is I'm going to write 3n. And how many times am I going to write it? I'm going to write it 3 times. Why am I going to write it 3 times? Because look at the exponent right here. That tells me I have to write it 3 times. So now what do I have to do? I've got to count up the n's. So I got n and n and n. How many of those are there? There's 3 of them. So I say n to the power of 3, because it's repeated multiplication. And what about these 3's? Well, I got to multiply them. 3 times 3 times 3 is 27. So I've got 27n to the power of 3. So that's my final answer. Okay, so take a look again. 6, 7, 8. Those were all with parentheses, and inside the parentheses I had a term, and that whole thing was being raised to an exponent. So I need to make sure, remember, that an exponent means repeated multiplication. Alright, so now let's move on. Now look at 9 and 10. 9 and 10 look completely different. So one of the things you need to remember is that this fraction bar means to divide. Okay, so what we're looking for is we're looking for giant ones. So what is a giant one? A giant one is anytime I have a numerator and a denominator that look the same. Numerator, denominator. Numerator, denominator. They are the same. Therefore, I circle it and I know that that means 1. Okay, so let's take a look. But wait a minute. There are no numbers. It's got a variable. It's a letter. Well, that's okay. So think about what we've been doing. N to the power of 2 means I'm going to write n times n. And what does the bottom say? N to the power of 2. Another n times n. So look what I've got. I've got the numerator and the denominator of the same. There's a 1. Numerator and denominator the same. Also a giant 1. So if I have a whole bunch of 1s, this answer is simply 1. So now let's look at number 10. Uh-oh. I've got divide. I've got an X on the top. Okay, good. I've got an X on the top. What do I have on the bottom? I have 4 times what? X to the power of 3. Well, how many times am I going to show repeated multiplication of X? 3 times. So I'm going to go X times X times X. Okay. I see a giant 1. She lined it up really well right here. So remember what I said. There's a 1 there. That's a 1. So what's on my numerator? My numerator is 1. And what's on the bottom? 4. What else is on the bottom? X. How many X's do I have? 2. So I have 1 over 4x squared. So that is this practice number 1. Yesterday we worked on this together in class, and then students, after we did this, took the quiz. If you are somebody that feels totally confident that can go from here to take the quiz, perfect. Then what I need you to do is come and see me, and you need to take the quiz. If you are somebody that would like a little bit more practice, I actually have a practice number 2. So I'm going to stop the video right here, and I'm going to make another video. And for practice number 2, the problems look just like practice number 1. Same number of problems, same number of everything. So go ahead, and if you need more practice, come and see me and take practice number 2, and then start the next video.